Alright, we'll be graphing hyperbolas. We already know what hyperbolas look like. To recognize that this is the equation of a hyperbola, the key is what?
Negative.
The minus sign. If it were a plus, what would it be? An ellipse or a circle, but in this case, since these two values are different, it would be an ellipse.
This is 10.5, right?
Okay? This, yeah. So graph, first thing we need to do is get it in standard form, just like we did with ellipses. This side must equal what?
1.
1. So what do I do first?
Divide everything by 225.
Divide everything by 225. And how do you reduce 9 over 225? Is it 25? So it would be x squared over 25. And how do you reduce 25 over 225?
Y squared over 9.
Y squared over 9.
Are they always opposite like that?
Yeah, I remember doing
Good
this.
question. Since we're dividing, no, it won't always be.
Alright.
It just worked out that way.
Okay.
So now it's in standard form, so we do the same thing we did with ellipses. We just pay attention to the number that's under the x, and that tells me what to do on the x-axis. So how many units do I, what's my center first of all?
0, 0.
0, 0. The center in this section is going to be 0, 0. So this tells me to go how many units on the x-axis?
25?
No.
No, is it 25 overall? So it'd be
5 and 3.
5.
Oh, yeah.
Because you take the square root.
Oh,
of
you take the
25.
square root?
So
Yes,
5 on
just
each
like
side.
we did with the ellipses. So I go 5 units in each direction on the x. How many units do I go on the
3.
y? 3 up and down. And those 4 points,
Is that the box?
that is where we make our box now.
Oh.
Okay, this goes back to what we did in the first section. We draw our box through those 4 points, and that will give me my
Why do we draw
asymptotes. Okay?
Why do we draw the box?
Why do we draw the box? So I can get my asymptotes.
Oh,
The asymptotes have to be lines going through the corners of the box.
Oh,
And
okay.
you have to label those also? You can't just leave it the box?
You have to label what?
Well, the
The
box
asymptote.
isn't the ground.
Yes, we're going to get to
Yeah.
that in a second.
Okay.
Alright, so right now just draw them.
So we're drawing a diagonal line like across it?
Yep, through each corner, because that tells us how wide we need to open our curves. Okay, now tell me which way to open the curves. So I open them left, right, or up, down?
Well, it's x. Well, the bigger one is x, so up, left. I don't know.
Well, the Y is negative? Is that? Oh, it's always going to be negative.
Yes. It's
Isn't
always
it
gonna
the
be
bigger
negative.
number?
No.
It's
not
a
like
smaller
the
number?
ellipse. No.
Oh, is that where you
It's
do like
the-
9 over 25 or something?
Well, let me explain.
Alright.
We open, in this case, left, right. We open along the x-axis, and the reason is, and you'll probably remember after I tell you, going back to the first section, because with ellipses, the x and y can switch places. Or no, sorry. Hyperbolas, the x and y can switch places. Ellipses, x has to be first, y has to be second. But for hyperbolas, they can switch places, and you open your graph along the one that comes first. Okay, so if y came first here, then it would open on the y-axis up and down. Got it? So since x comes first, we just open it along the x-axis, left,
So
right.
x is
Is the
left,
x
right,
always-
y is up, down?
If x comes first,
Okay.
it's left, right.
What if X not come
If y comes first, then it's up, down.
first? Could it ever be like left
Yeah.
up?
No,
You can switch it around.
No.
Or would it have to do with the base here?
no, this is one shape, they either open left, right, or up, down. Okay?
I
Now
still
the equations of these asymptotes, I'll ask you that as well. There is a formula, but just by looking at it, slope-intercept form. What's your y-intercept for these both lines?
0, 0.
0. Okay. And how do you calculate from this point to this point? All you gotta do is rise over run your slope, right? So you rise 3, run how many?
5.
So your asymptote equations,
We
the
would find
first one would be
3 over
y equals 3/5 x, and this one would be y equals negative 3/5 x.
So your asymptotes are basically your slope?
Yeah, no, I mean your
No.
asymptotes are lines. So to find the equation of the line, and slope intercept, when you need a
okay.
slope, you need a y-intercept. Now there's an easier way to get it. They're always y equals plus or minus b over a. What is your b value?
9.
Oh, b over a.
It was 9 is b
X.
squared.
Right.
Oh, so
B,
isn't it
your b
x over
value
a
is, in this case,
9?
9. Square root of 9 is 3. Square root of 25 is your a value, which is 5.
Oh, because it's x squared, a squared minus y squared over b squared?
Correct.
Alright.
Okay. So I would recommend just, I mean, if you want to remember this formula, that's fine. If not, just count the slope and you're done for the asymptotes. But for hyperbolas, your a value does not move. This number is always your a value. This number is always
Wait,
your
so
b
you mean
value.
The first
So
one or the
going
one with
back-
X?
Hold on. Going back to ellipses. X and Y can't move, A and B can move. For hyperbolas, X and Y can move, A and B do not move.
So the first number is always A, and the second number is always B.
For a hyperbola, yes. It
Okay.
doesn't matter about the large one and which one's larger.
But the one, the X can change.
Correct. Okay. All right, let's look at another one. All right, here, that's already in standard form. Now we gotta find the foci. Now the formula here is similar to the one for an ellipse, for finding the foci, but it's not the same. It's the Pythagorean theorem. A squared equals a squared plus b squared.
So
For
we're
an
just,
ellipse, it was minus.
So
For a hyperbola, it's plus. That's how you find the foci. Alright, so let's graph it quickly. What do I do on the x-axis?
you go 6 double.
6 units in both directions. What do I do on the y-axis?
2 units.
Both directions.
2 units both directions. And draw your box. Draw your asymptotes. What's the equation of the asymptotes?
it's 2/6.
2 over...
1/3.
Yes. Y
Y
equals
equals 1/3 x and y equals negative.
plus or minus 1/3 x. Okay? And do you open it up, down, or left, right?
Left, right.
Left, right, because the x is coming first. Now, your foci,
So where are the foci, like located on the graph?
well, let's find out. Well, it's just like a parabola, it'd have to go inside.
So it has to be inside like the box thing?
No,
No?
it'd be, just treat this like it's a parabola, where it
Oh,
has
so
to
it's
go
gonna be inside
inside,
there.
somewhere in here and somewhere
Oh,
in here.
okay,
So
okay.
let's use the formula to find the foci. So c squared equals, which one's a squared?
36.
36. B squared?
4.
4. C squared equals
40.
40. So somebody tell me what the square root of 40 is?
6.32.
6.32, which makes sense. So you would just approximate
So just
where
guess
they
about
are.
6?
So about right here, we'll say.
Alright.
So the coordinates would be
Is it-
6.320 and negative 6.320.
Are we moving the 6.3 from the vertex? I
No,
mean, from like the center of the graph or from the opening of the parabola?
what?
Are we doing the,
No, just from the
just from
center
the, okay.
is your, where you go. All right, the only reason we did that for our parabolas is because our vertex was at 0, 0,
Okay.
so it didn't matter. Yes?
When we're graphing, do we have to draw all of that, or do we just really have to draw the, hyperbola?
You have to draw all of this because you have to know how wide to open your,
But can you
Graph,
just kind of
curves.
tell?
no,
Like,
I mean,
that
if you don't
point
draw
goes-
your asymptotes, you might just draw a big curve that's going in any direction.
Well,
So I want to see all of that when you, and you have to draw the box in order to get the asymptotes.